All right. So uh, I would like to quickly get started with the introduction, and this is the outline of my talk, where I've organized to quickly give a introduction on the virtual reality sort of technology, and also in the part one I'll try to cover the practical relevance, and then in the part two I'll try to take you through various application and case studies, including one of the DST funded project that we have done, primarily not on, I mean, it is extended version of virtual reality, going one step ahead, how we can make use of that technology for further incorporating IoT and then digital twin, etc. So that would be kind of case studies I've planned in the part two. So quickly, just to touch upon the various kind of research verticals that I work on, primarily on the manufacturing and product development, particularly the sort of VR and then digital twin, and then the image related processing technologies are one of the kind of vertical which we use it primarily for kind of developing products, and then the ensuring the quality, and then its end use application. So my part of the talk would be addressing towards this vertical, although we try to work on various other research vertical also. All right, so what I've planned is, quickly I want the participants to just to cooperate with me in this activity, which is a quick exercise, trying to understand how much of the sort of awareness on this particular VR all of you have. So I request the participant just to quickly scan this QR code, and then try to give your responses, and then let us see like how many of you are familiar with this virtual reality in sort of education as a application, sort of a domain. So I would encourage the participants just to quickly scan and then register your responses. You will find all these options as you scan this QR code, and then you can sort of give your responses, so that we can understand what is the kind of participants. Okay. All right. So I think at least 3 responses are at the moment going. Some of them already using sort of VR technology, the teaching. That's good to know. All right. So there is a one participant like me. VR is completely new to me. Okay, good. I think there are more number going into the heard of or explored VR, but don't use it actively, right? Hope the participants can see the responses which are coming out here also.
Yes, sir. You could see it.
Okay. Yeah, thanks for confirming that. All right. I saw there were at least 100 plus participants, and roughly about 21 responses recorded so far. Okay, I think by and large in all options we have fairly distributed sort of numbers. Yeah, maybe in a minute we'll try to wrap up and then move to the sort of next question which I have prepared. So application part straightforward. So that's the basic sort of requirement for me to kind of prepare this data. So for 25 responses, not bad, great. Probably I understand some of you might be finding difficulty to sort of access and then register your responses. All right, not bad. I think 26 responses. So four of them says that I've used VR regularly in my teaching. That's good to know. And then the at least 10 responses, which is the highest, at least, have explored VR but don't used it actively. Okay. And then the third response, I'm curious, almost like, but haven't tried yet. Okay, 6. VR is completely new to me. Okay, so that is also catching up. Okay, fine. So fairly we have uh, at least new sort of audience for this topic, which would be kind of at least hint for me to give a kind of some basic sort of understanding. Of course, I've prepared my presentation in that direction as well. All right. Yeah, thanks for the sort of feedback. At least 30 feedbacks. It gives me a good understanding. So let's move to the sort of next question. So here I just wanted again the participants to sort of at least for the new comer or the participants who first timer for VR, what word sort of comes to your mind when you think of this virtual reality in education? You can just scan and then probably type. Okay, imagination, right? So you have to scan the QR code and then type your word. It'll flash here. Yeah, already we have one response, imagination. Great. Okay, interaction. Yeah, great. So immersion. Okay, creativity, different dimensions. Okay, easy to understand. Yeah, I think that's very important. Making the user feel. Okay, immersive environment. All right. Okay, sequence. Okay, interesting responses. Thanks for that. Yeah. So far, I think 9 responses. Okay, not real. 3D display, Unity software. Okay, fine. All right, fine. So I mean, a lively experience mhm, of real. Okay, fine. Yeah, deeply connected. All right, simulation, engagement. Yeah, innovation, exploration. Okay, great. So I think by and large, kind of the words like live experience and then the imagination and the creativity, immersion, all this sort of engagement are all kind of activity wherein the moment when we try to bring in this virtual reality into education. Great. So 31 responses. Thanks for the participation. And let's quickly move on to the third response. This is probably for the first four who sort of of course I know this might have been redundant, but for the first question, those who answered at least 4 responses were coming up, like they were using already VR in the teaching. So what sort of challenges that you sort of foresee, and of course for the others who responded also kind of give, like what kind of challenges that we can foresee while adopting this VR for teaching in your respective field. For example, I'm from mechanical engineering, the others could be electrical, computer science, etc. Okay, supporting software, yet to use VR. Okay, resources availability at the college, definitely yes, that is one of the kind of bottleneck, I would say. Right. All right. Any some more? Okay, lack of hardware devices. Yeah. Technician compatibility. Okay, a skilled sort of trained technician. Okay, fine. Yeah. A poor knowledge to handle and need much technical support to handle it more effective. Also need to be updated with newer skills, etc. That's what exactly Dr. Usha was pointing out. Yeah, not knowing the proper way to handle VR, etc. Okay, all right, fine. Yeah. So I mean, typically, if you see, there are I would say summarize the kind of responses. One is the resource or the lack of infrastructure and the trained manpower or technician to handle these sort of a thing, right? So we can take up this as the sort of outcome. Thanks for the response. Probably with this we will sort of conclude this activity and then move ahead. So quickly, some of how do you think, which of these applications of VR in learning do you find the most impactful? You can give your uh, responses like 1 to 5. Okay, virtual labs for practical experiments. Yes, indeed. Virtual field trips to inaccessible locations. Yeah. Okay. Oh, good. So 8 responses so far, but the first one seems to be the dominating. Virtual labs for practical experiments. Yeah. Okay. The second one is also kind of very sort of interesting application of VR, where we can promote the collaborative sort of atmosphere between the students, especially for the projects with the team of let's say 3 to 4. Yeah. All right. So 18 responses, 19. Okay, great. So there are at least 20 plus active audience uh, participating in this. I'm really thankful to them. All right. So this is just to give you at least the fair idea of how this VR could be used in learning with the sort of 5 different sort of domains or verticals where we can package this technology and then make a very fruitful and engaging teaching learning process. Okay, so in fact that is happening, and then I think that is the purpose of this FDP also, wherein we should as a faculties try to get acquainted with the latest technology and then try to use it in our as a part of our teaching pedagogy. Okay, all right. So great. Thanks for that. And then I think let's move back. So at least with this quick exercise, going through those 4 questions, we got at least a feel of the uh, distribution of audience who are kind of in and around, or they are exposed to this uh, this VR technology, and then how it can especially be sort of implemented in the learning environment, particularly in academic institution, right? So now I've also sort of given you. I wanted to take you through this particular kind of practical application for those who are actually new to it. And of course, Dr. Tune Usha was also mentioning about her experience in shopping. This is also related to shopping. Just to give you a feel of how it is being used. All right. So this particular sort of case study actually is trying to demonstrate the augmented reality, right? So that's what Dr. Tune Usha was also mentioning. So it is kind of uh, collaboration with virtual reality and then the AR, which is augmented reality, where the kind of concepts or the sort of the designs that we saw in the furniture layout, etc. It's the IKEA is a big furniture sort of maker, and he has, I mean, they have used this technology primarily for the customers to give their kind of user experience, especially by sort of having their own floor layout or the interior design which would be compatible with their whatever they design of their, let's say, living hall or bedroom, etc., wherein they can actually customize and then pick the design and the format and the kind of design theme depending on the requirement, right? So therefore the virtual reality and then the augmented reality combined together makes a big impact, especially on the requirement of the user, so that the companies like IKEA, and of course there are many such companies, for example, Lenskart, for example, they also sort of make use of the frames, okay, which would be more compatible and then very trendy, and then the design specific, etc., will be more specific to the user that they are using. So those are all comes under the category of your augmented reality, where we try to make use of this additional layers of whatever the feature that we create on the physical sort of layout. It could be the interior design for the your house, or it could be choosing the glass frames for yourself, etc., comes under that category, right? So with that background, I want to quickly take you through the kind of evolution of this virtual reality. Okay, so you can see it started way back uh, almost like 1838. It more like started with the stereoscopes, and then subsequently the kind of spectacles in 1935. And then this is very interesting. I'm going to spend some time on this 1962, where this sensoroma is a kind of virtual reality sort of hardware which was kind of patented. And then subsequently the squad of Damaculs in 1965. And then as the technology evolved, you can see at the moment we are almost like having this kind of a gadget through which we try to see the kind of virtual reality, which is being sort of giving you the more visual perception and the feel, imagination, and then the engagement with the sort of the content which is already preloaded. Okay, so now quickly, as I said, I'm going to sort of spend some time on the sensoroma, which is very interesting, especially so you can see this is a sort of US patented sort of technology in 1960s, where this is the actual sort of hardware. Okay, so the user sort of will be kind of made to sit here, and the inventor is primarily a filmmaker, and of course the Martin Heilig is also a kind of, as another, he wears another hat as an inventor. That's how he invented this sensorama. Okay, so basically his sort of motivation, or rather dream, was he wanted to take, as he was a filmmaker, take the future of the cinema, primarily kind of making this user experience getting into the cinema, like they have to sort of get immersed, and they should travel with the story, and then they should get the feel of it. Okay, so that's the kind of I would say dream which he had. And in fact, this sort of sensorama was primarily made to get the sort of the motorcycle drive through a New York City. Okay, so this is the user experience. So as the user sits here, and then kind of there will be a kind of handlebar, and then they will be trying to have the experience of this motorcycle ride. Through that, the features that this particular sensorama captures are the stereoscopic color display, especially for giving you the 3D visuals, and it also gives you a stereo sound. Okay, and there is also kind of fan attached to it to generate the wind, right? Like when we ride a motorcycle, you'll get the feel of that wind as well, is it not? So, and then also the odor emitter to produce kind of sense depending on the whatever the kind of scene, that to get the feel of sensory organs. And also there is also kind of motional chair to simulate the movement actually. Okay, so there will be kind of when you actually ride a motorcycle, you will get unless and otherwise it's a flat road. Depending on Indian roads, you'll get a kind of the picks, etc., so you'll get a jerk, etc. So to get that motional sort of movement, also there was a technology or a mechanism which was sort of incorporated into it. So you could see that this is actually giving you the user experience, although the user is sitting in a stationary position without on an actual motorcycle. He would get the feel of riding a motorcycle through a New York City, with all these feelings getting captured, the sound and the feel of the wind, also the odor and the kind of movement, etc. So that's how this is more like one of the kind of celebrated sort of I would say the patent at the time. And then subsequently he had that sort of innovation, or the creating such kind of new features or the technologies for better user experience. Okay, and of course this is actually a kind of I would say fully immersed VR technology. Okay, but there are also recently, probably the audience might be able to get connected. There are non-VR or non-immersion VRs which are also being used by government sectors. Like for example, you can see here, this is, I'm talking of 2022, And of course, this is very, I mean, this is, I think, a very around 2019 or so, although I took it from today. So this is just to give you the feel of the simulator experience, especially for the, the learners of four-wheeler, to get the feel of getting the more exercise or training before they actually go on to the actual final driving test. Okay, so these are all more like non-immersion sort of virtual reality. Okay, but this one is fully immersed because now you could see that this is almost like you're actually detached from your physical world. You are being fully captured into the actual, whatever the kind of the user, I mean, the kind of visual effects, sound, wind, etc., movements, and the scent, the odor, etc., are being completely you're immersed. But here, this there is a not you're being detached, therefore, from the kind of full immersion, because you have a flexibility to, of course, if you get sort of a difficulty, you can always see here and there and not actually getting immersed into the actual the training program which is going on, right? So therefore it is kind of non-immersion, or not fully VR sort of technology, right? And of course the similar kind of thing is also being extended, especially for the pilots, the aircraft pilots, as a kind of training sort of exercises, wherein they'll be sort of subjected to varying sort of activities, right from the landing to turbulence and then the taking off, etc. All those exercises can be simulated before they actually get into the thing. So you could now at least connect with this the aircraft pilot training exercise, because the kind of activity or the risk that is being involved while learning the aircraft, okay, as a new pilot, or a not having sufficient experience on the aircraft flying. So in those scenarios, the kind of cost involved are really very high, and also the risk. So therefore you can sort of understand the implication or the advantage of this virtual reality kind of applications playing a big role in trying to train the pilots in this scenario. It could be a different in different application. That is what we are going to see in the part two of my talk. Thereby, the uh, person who is not well trained, I mean, equipped for handling whatever the very expensive engineering equipment or machinery or a sort of system like aircraft, can be made to sort of go through a very rigorous training by going through all the scenarios, and then he could be sort of made to have a lot of confidence before he actually goes on to the actual, let's say, aircraft system in this example. Okay, so that is the kind of implication. And just to connect to you, why this virtual reality sort of thing is popping up and then mushroomed over the years, and what is its business potential or the global market potential. You can see here, sort of from 2023, and of course we are now here, and then to 2028, primarily for the gaming industry, it is continuously growing. Okay, the CAGR value is on a constant sort of increasing trend that sort of gives kind of understanding why it is playing a major role, or it is gaining a lot of traction in current days, different applications. And this is just to give you the relevance, especially in the education field. I request the participants to sort of mute their audio so that it will not be disturbing the other participants. So thanks for that. And you can see here, this particular slide is primarily focusing on the education field, and of course this is also not really lesser than the gaming, because gaming I just took it up because the current generation of students are more attracted towards this gaming and entertainment using this virtual reality. And you can also see the education that is also more focused for the today's younger population who are focusing on this various educational sort of degree programs. There is also continuous increasing trend. Okay, so from these two slides we could able to understand there is a lot more traction as well as emphasis that is being laid, especially from the manufacturer's point of view, looking at this VR technology as a kind of very potential and then high profit volume kind of business. Okay, so that is also kind of one of the kind of motivation that we can derive from this, especially in the education as well, which is perfectly into the context of this FDP program. Okay, so just to give you, although I mean I've planned my talk in such a way that I'll not talk, I will also make use of this visuals. Although there are advantages and then good potential in terms of business, etc., there are challenges as well, right? So for example, that was my sort of third question, like I was asking what was the kind of challenges that we encounter. So you can just, this is just like on the fun side, you can just understand how a user who is trying to use this is encountering the challenges. Okay, so this is just to give you the you know uh, one of the challenge, and of course that is the kind of the fully immersion VR technology. When you have this kind of VR sort of goggles, you're actually detached from your physical world. Okay, so therefore that offers of course challenge like this when there is a kind of motion or movement involved kind of, let's say, games or training programs. But the other part of advantage is that it is being fully immersion kind of sort of a scheme. You will not be interacting with your other physical world, therefore your full concentration will be there in this. In fact, there are quite good experiments that are being used. Of course, for the sake of time, I've not used that, but orally I can mention that, especially when we use this VR sort of boxes, especially in the education sector, how it is actually making a kind of connectivity or interaction with the student. They could able to track the eyeball movement, and then they actually get a data whether the teacher, wherever he points out on the particular whatever the slide and the video, and whether the students are also trying to focus there or not. Okay, so their concentration, focus, etc., can be tracked by the eyeball movement. Okay, that is only possible when they are being used using this kind of a VR gadget, which is actually giving you the which is actually detaching you from the physical world. Like for example, the challenge that we saw, since they were able to kind of detach from the physical world, they are not able to realize what is there around them, and then there is a kind of collision with the walls, doors, etc. There is a possibility. Okay, so this challenge is more like can be looked at as a kind of advantage also, while understanding what is the kind of impact of this VR technology, particularly from the student perspective, in understanding what is their concentration level and the focusing aspect in the actual VR content, etc. Okay, so this is just I wanted to kind of bring it out so that you could able to connect what we are trying to understand from differentiating between the fully immersion VR technology and the non-immersion VR technology. Okay, all right. So that's the kind of part one, and I've would like to take you through the part two. Before that, if there are any sort of questions, I would like to take now, or towards the end, Professor? What is the plan?
So at the end of the session, we'll take, sir.
All right, fine, no problem. So thanks for that. So in the part two, I've planned the various applications, trying to give you the we are example in this case hard and trying to have a better interaction with their professors or the faculties, and then trying to understand better, and there could be sort of more um, effective teaching learning process that is possible. Of course, even during sort of surgery also, that is more relevant in trying to understand, for example, even for the experienced doctors when they actually go for surgery, okay, to estimate what could be the operation time, okay, or the what is the occupancy time of the OT, operation theater, etc., to plan and then manage those, let's say, number of surgeries that are planned on that OT. Let's say if we talk of a very big hospital where there'll be some hundreds of surgery happens in a day, okay, and how do you sequence them and how do you estimate the time, right? So that could be done as a part of trying to create these sort of virtual sort of dummies, and then trying to understand to plan their surgery very effectively so that they will not be wasting their time in the on the actual patient, okay. So that sort of opportunity also exists, especially with respect to this medical education and hospitals scenarios. And the very important another application is the military and defense field, okay. So this is very important, especially for the newly recruited, let's say, the soldiers, okay. So for them, if they have to be trained, okay, they could be they need not be taken to the actual war field kind of scenario, right? So they can be sort of trained on the simulated war field kind of situations, and then they could be sort of assessed how much they are able to respond to the kind of emergency situation. And then, for example, there could be scenarios where for the aircraft pilots, just to estimate what could be the distance from reaching from point A to point B, and then accomplishing the task, and then how long the SARTI would take, etc. Everything sort of can be done on a more like simulated environment, and then that would, for example, save a lot of investments or the expenditure, okay, on training them, okay. And then second thing is that although this device is something like available to them, they can keep continuously practicing unless and otherwise they become more like perfect and then confident in handling like the advanced ammunition or rifle systems, and then they could able to perform better, much better in the actual scenario, okay. So that is the more like interesting sort of application in the military and defense. And this is just I connected with this disaster management scenarios, especially the taking an example of this coastal hazards, because I think Dr. Tune Usha is pertain to this expertise. So this VR could impact, in fact, could be more beneficial in terms of let's say there could be a kind of flooding, or there could be a kind of uh, tsunami, for example, in that kind of context, what could be its 3D visualization, and how do we plan the evacuation in the nearby, kind of people who are residing, and then what could be the search and rescue operations, etc. How do we do that, and then for example, the damage assessment, especially post kind of scenarios, post damage scenarios, we can actually look at and then map the assessment, and then trying to understand how do we sort of recondition them, and then plan to raise the infrastructure, etc. All those sort of things could also be kind of looked at in more deeper sense, right? And of course, this is shopping and e-commerce field, which I also touched upon as a part of my first part, where you can actually get the, for especially the shopping sort of scenarios, you could get what is the product, and then this is primarily important, both for the owner as well as the customer, trying to understand what is the stock available and what kind of variants, etc. Everything could be kind of mapped, just getting onto this, and also this is in terms of this is non immersive, and this is more pertain to the fully immersion kind of schemes, trying to understand the things. And not to mention, the travel and tourism is also very, very exciting field for this VR. Primarily, when we try to plan any uh, kind of destination for our travel, in fact, upfront we can plan all our itineraries, and then what are the things to see, and then what is it is famous for, and how do we do that, and all those things. Although those information can be done manually, but this sort of VR application actually gives you a kind of feel for you to take a call whether you actually wanted to visit that place, or you want to skip in the interest of time and then spend more time on the other destination, etc. Planning can be done in that space also. There is a lot of potential which are coming up. Okay, and of course, the gaming and entertainment is, as we saw, the kind of the demand for this industry is evolving, and there are big potential for this particular field, especially from the VR, and of course complemented with AR and MR, the mixed reality kind of technologies are also kind of having a big scope there, and applications are plenty. And the construction and architecture engineering, okay, so that is also one of the a very, very impactful application, I would say, because these kind of buildings or the architectural designs can be sort of upfront seen, and then you can get the feel, and the client approval, and then so on, can be made very, very easily, seamlessly, the moment when you bring it up in a VR technology framework, which would give you the complete feel and look and aesthetic of the entire project. And then the client will subsequently, if he wants to kind of do any modification upfront before executing the project itself, the all necessary iteration, design modification, and architectural, the outlook and elevation view, etc., can be very seamlessly modified, and then they can actually freeze it, and they can go ahead with the actual construction. Okay, so those kind of opportunities are also kind of evolving, and people are trying to make use of this VR technology, and of course complementing with AR and MR in a big way, so that they can take advantage of this technology for finally getting the final user experience out from this part of construction and architectural engineering. And the manufacturing industry, because I mean, one of our project is funded from DST, which I will be touching upon in the upcoming slide, is primarily on the manufacturing industry. This is being used quite extensively, because you would think of a very big manufacturing industry wherein a machinery undergoing for a maintenance, okay, it will be of big headache for stopping the production for that day or for that week, until unless that machinery has been made to revive back to its original operating efficiency. Okay, so how do we do that, right? So all those aspects can be captured, and then in fact we can actually capture all those details of bill of material, and then trying to understand, and then even this could also be used in the uh, training the new engineers. They will be joining the industry, thereby the kind of cost of training etc can be minimized, or can be brought down, and that could be a potential cost saving for the industry. And applying the similar framework in the engineering institution also, the similar kind of technology whatever I've touched upon right from the beginning to here can be used in a more like immersive way for the student to get the complete understanding of whatever the technology, theoretical concept, engineering concepts that are being explained more in a theoretical fashion can be brought as a 3D visualization, and each and every subcomponent of it can be visualized, and the student can try to understand and connect the concept that has been taught by the faculty, and then he would be getting a better understanding through these sort of VR technologies that are being used. Okay, and of course, just to give you insight on the manufacturing industry, this BMW automobile manufacturer, I'm sure all of you must be aware of it. Okay, I think, yeah, I think I've missed out that. Not an issue. So this is just to give you an insight of how that can be used in the automobile industry. Okay, the links anyway can be kept. Okay, now quickly trying to connect to the kind of academic institute, right? So you can see that in most of the kind of lecturing classes, okay, so the student, especially in the current scenario, they tend to find it more boring. Okay, of course this is more from the viewpoint of science, and that could be applied to the applied science also, and also ineffective and expensive. Okay, so how, I mean, this is the kind of challenge, especially for faculty like us in the engineering or even in the other non-engineering academic institute also. So how do we sort of make, let us say, this teaching learning process more effective, and then that would be more useful for the student community, so that they can, because they are going to be the future engineers, and then they are going to take a lot of responsibilities on their shoulder to actually deploy whatever the engineering technological related decisions and inputs etc, the skills that are required are need to be kind of made very clear for them before they go out of the academic institute. So in that perspective, this VR technology is becomes quite useful, especially for teaching learning process. Therefore, this is another application field, and that's what kind of I'm going to kind of quickly touch upon in the upcoming slides, how it has actually benefited, especially looking at as a technology. Okay, so now this is one of the research data actually. Okay, so this is primarily trying to understand how the science school experiments, okay, the learning process, how they can be sort of understood more effectively. Let us say this is the kind of score in terms of the understanding, and the x-axis you have the traditional way of teaching, and this is we are sort of based tech industry labster. I'll just show the video related to that in the upcoming slide. Just the point which I wanted to highlight here is that you can see that there is a good increase, I mean, of this score in terms of when we move from this traditional teaching process to this VR based kind of a process. Okay, so that is something phenomenal. The moment when this VR sort of a technology comes into our teaching learning process, the students are more interested and they have more attention, their concentration, focus, etc. are quite significantly enhanced from the traditional sort of a thing. So what we find, of course, this is the same data. 76% of the sort of enhancement that we can observe, the point we move from traditional teaching sort of scheme to a VR sort of a thing. Okay, and further, when you look at this, is more interesting when we kind of make a combo between the traditional teaching and this VR. You could further see from, of course, only Labster alone, there is a kind of marginal improvement, but comparing it from traditional teaching, you will see almost like 101% of enhancement in this learning score. That actually I would say, kind of impactful sort of thing that is happening, especially in the teaching learning process. Okay, so this is the kind of the Labster which I was mentioning, which is used in education. So this is the kind of product you can. VR application sort of complete package are all available. I think it looks like these datas are from their thing only. It appears that there is actually a kind of improvement in the teaching learning process. Okay, fine. So that is about kind of application of VR technology in education. And then now I would like to quickly take up the kind of project that we sort of handled and then completed, of course, that also resulted in a more like a patent for us. And I would like to, touch upon how this sort of, 3D visualization sort of technology or techniques can give you better insights, and it can be of great value actually when we deploy it into actual industrial scenario. And of course, this can also be used in a teaching learning process also. And first I would sort of touch upon on the how it is more like useful for the large scale industries. And this is the kind of 3D holography based digital twin framework, okay, for an induction motor. And digital twin is very similar to, I would say, VR, but it can do a lot more sort of functionalities compared to VR. Okay, so you can see this is the actual sort of motor, okay, induction motor. What we do is we try to create a 3D visualization of the same motor. Okay, we call it as 3D CAD model. All right, and what we are going to do is, of course, the same thing when we try to bring out what is its bill of material inside the induction motor. That becomes more like a theory and visual kind of understanding for the student when we uh, teach them using VR. But this digital twin is kind of a very advanced kind of technology. Again, of course, it also has a relevance in terms of VR, because we are able to visualize this physical, whatever the thing which is being in a more like a virtual reality in a three-dimensional sort of framework, right? But let's come back to this digital twin. And of course, twin is, of course, it's more like replicating its physical asset sort of a thing. And what we are interested is to kind of understand or record what is the operating characteristics or conditions of this induction motor. Like for example, we might be interested in what is the current value as the motor runs, what is the kind of earth leakage current, okay? And since the motor will be running in higher rpm, say 1000 and 2000 rpm, what is the vibration level, okay? And of course, since the current is getting leakage, what is the kind of power that is being consumed by the motor, right? So these are all some of the information, very important information that would give you insight on how your motor is performing, or is your motor healthy or not. Okay, so all those kind of insights one can get. And in fact, this is the bottom graph that you see. As this motor runs for different kind of period, like various time period, you can actually understand what is the condition indicator. Like for example, you can predict when the motor is going to fail, for example. Okay, you can see there is a kind of prediction at 65 cycles, 100 cycles, 145 cycles. So what is the purpose of this information? So when you can predict, okay, my motor is going to sort of fail at 65 sort of cycles, so how do I prevent that? What kind of maintenance schemes that I can adopt so that I can avoid this failure of this motor, so that my manufacturing production line will not be stalled or stopped for the maintenance. Okay, all those pre kind of activities and then maintenance schedules, etc., can be maintained well ahead of your motor undergoing failure. Okay, these sort of schemes can be done by actually make after making this 3D CAD modeling, we will sort of do a mathematical kind of simulation, and trying to extract the simulation results, and then we try to map with the physical kind of understanding. Like for example, this is a kind of actual motor which we made to sort of run, and then we used various sensors, like the to capture the vibration, temperature, and also the power, current, etc., as it rotates. And then we map this data with the theoretical sort of mathematical results that we got. And from that we can actually superimpose and then try to understand how they actually this is the kind of data that we get it from our mathematical model, and then we try to compare it with our the actual sort of motor running, and then we try to understand whether they are kind of having a similar kind of a correlation or not. Okay, so based on that one can predict the maintenance schedules that is required, etc. And of course now this is of course the kind of dashboard one can see it in a non-immersion sort of framework, or you can also use VR goggles and then trying to understand what is my rpm of the motor, torque, voltage, temperature, power, current, etc., like a more like a dashboard scenario. And then one can get the insight of what is the condition or health of the motor itself. Okay, and of course the this one I just wanted to highlight, the visualization that I was mentioning about could be sort of looked at by using a 3D holography kind of framework. This is a non-immersion based VR sort of technology framework, wherein this can be more like displayed. It could be displayed on a shop floor in a manufacturing industry. Motor condition that you see here, all this XYZ, and then the voltage, torque, etc., are all continuously changes as the motor runs. And then if there are some malfunctioning that are happening, there will be a kind of alarm, and then sort of popping up that would arise, come up on this display, holographic display, and then the necessary sort of preventive maintenance kind of schemes one can, the industry can take, and then they can avoid actual failure of this motor well before the time, and then they can sort of make their production seamlessly, going in order to meet up their production schedule. Now, of course, this is more like a part of the previous work, and of course we have sort of patented this thing. And now of course that is the kind of last application that I wanted to show. And as a part of this FDP, I just wanted to sort of give you or at least understand our role in terms of understanding how we can equip ourselves in technology adoption. Okay, and that becomes a kind of pivotal role, so that the students whom we are teaching, or kind of making this teaching learning process more sort of productive, as well as fruitful, so that they can actually get into what is the concept is, and then they can actually get the insight in a better condition, rather than going ahead with our traditional way of doing the teaching learning process, right? But of course this is a quick sort of VR box. One can do it yourself at home. Of course this is the YouTube link, one of the YouTube link, and there are a lot of videos available, in just in case if you want to make yours VR box by using your mobile phone. That is possible. Just I wanted to bring this up and then show that. And now this is the kind of concluding sort of a thing slide from my end. Before that, I've planned a quick sort of quiz, trying to understand how much of the thing has been sort of uh, got by the audience. I would like to quickly request the participants to, based on the talk, what did you sort of understood as a primary aim to achieve this through VR? Okay, quickly scan and then give your responses. Let us see. Okay, already I see one response coming up there. This is more like a multiple choice question. I'm trying to see what is the primary objective of VR. So far, 8 responses, not bad. And majority of them are going towards immerse users in a digital environment. Thank God I'm not seeing the third response, that is improve internet speed. 0 response there. Okay, 17 responses. Great. Okay, great. So 20 response. So majority of them are going towards immerse users in digital environment. That appears to be the primary objective or aim. Of course, there are kind of the other responses: enhance 2D graphics on computer and reduce the need for physical hardware. By and large, they are there, but the primary thing is more like immersing the user in a digital environment. Great. So at least I'm kind of satisfied with this more than a 1 hour of interaction. I got at least 17 of the participants giving a more closer answer. So the second question: which of the following is not an advantage of VR? 4 responses. Okay, 16 responses. Nice. Majority of them going towards can cause motion sickness in some users. 24 responses. All right. So the last one I could not able to see, enhances the physical interaction with the real world. Okay, great. So in fact, that is the kind of more closest answer. Enhances the physical interaction with the real world, right? That is not the advantage of the VR. For example, we are actually simulating and we are detached from the physical world, right? That's how, that is one of the challenge in the VR thing. Of course, this is kind of slightly tricky question. Thanks for the attempt. Great. So with this, I would like to, thank you for your patient listening, and then over to the organizers. Hope I am on time. Hello, Professor. Am I audible?
Yes, sir. Yes, sir.
Yeah.
Thank you, Professor. Participants, if you have any queries to interact with the professor for any clarification, you can now raise your questions. Participants, if you have any questions related to the content with respect to the introduction of immersive virtual reality, specifically in the application of teaching. Moreover, our professor has explained and put up in a very clear way of understanding the different way of different applications and case studies with relevant to immersive technology. So take this opportunity to raise your questions or any clarification doubt. Even you can put up in the chat box. So there's one question, Professor, here.
Yeah, please go ahead.
Can I use my mobile phone as VR?
Okay, in fact, the kind of this DIY thing is, they have actually used the mobile phone. Okay, so you can take a look at this YouTube video. Of course, if you just type DIY 3D VR, how do we do it yourself, kid? So they have actually used the mobile phone. Okay, and of course, that is more like on the trying to make it very simplified version, not the one that is commercially available. Yeah, I think that is possible. You can make an attempt. Yeah, is there any other questions,
Yes, sir.
Professor?
There's another question.
Yeah,
Need to
please go
draw
ahead.
a 2D and convert into 3D. Any tool apart from CAD?
Sorry, come again.
The question is, they need to draw 2D and convert into a three-dimensional. Do any tool apart from CAD? So
Okay, at least in
yes,
mechanical engineering department, and then civil engineering department, they use the CAD packages quite heavily to sort of render 3D CAD models, right? So at least I'm not sure. I mean, is it more like from the engineering perspective, because there are some uh, generative AI based sort of softwares are all evolving, where if you just sort of give your even text, they will give you a kind of 3D models, right? So there is a kind of ongoing sort of activity, but at least I'm not sure of commercial software packages at the moment. But CAD packages are very well known, as pointed out by the participant. So maybe some AI generated, AI based generative sort of uh, you know tools might be maybe relevant. Maybe that can be attempted. At least to my knowledge, I've not come across apart from the CAD, which are more commonly used in the engineering domain. Yeah, Professor. Any other
Yeah,
questions?
yes, yes. There's another question is how to compare results of 3D hologram model and actual one.
This is from, I think, probably
Mechanical.
our own
Yeah.
project, I think. Yeah. So, okay. So what we have done is, like, for example, this is the theoretical data, as I was mentioning, voltage, current, and the RPM of this motor as it runs, and then the corresponding power it draws. So this is something like we can actually generate from the system, the system identification tools, like using this MATLAB. We have this state space modeling. It is more like electrical sort of the theoretical framework. Based on that, we can actually get this values. Additionally, what we are going to do is we probably you can see there are this is a accelerometer which is being attached to this motor. As this motor runs, it is going to capture the kind of vibration signals, and similarly there is also kind of the temperature and then the power meter which are connected, which are going to generate similar kind of data. So obviously the kind of correlation, that if we can see the theoretical values and then the experimental values will not match, because of the kind of theoretical model will assume certain assumptions. Okay, so there'll be deviations, and what we are going to do is in the first initial stages, we try to kind of correct this deviation. Okay, and then try to add a correction factor, and then try to get this correlation done, and then subsequently we try to generate lots and lots of data, and then we try to do a AI ML kind of algorithm to train on those, and then we try to predict. I mean, the ultimate aim of thing is to sort of arrive at these kind of graphs, where what is the kind of time period before which we can predict the failure. Okay, so that the kind of catastrophic failure which can come onto this induction motor can be avoided, and therefore the production line with which these motors are running can be also made to not undergo kind of shutdown kind of scenarios. Okay, so therefore you can actually encounter those things and then get the thing. So this is how we go about kind of doing the whole exercise. Yeah, Professor, hope I answered the question. Any other questions?
That's it, Professor.
All right, fine. So I think thank you so much for the questions. Of course, very interesting ones. And yeah, Professor, over to you.
Thank you, Professor. Thanks for rendering the service to adding a value to our faculty development program on virtual reality. May I request the co-coordinator Soumya to take it forward. Soumya.
Thank you, sir. Thank you, Dr. Anand, sir, for such an engaging and insightful session on Introduction to Immersive Virtual Reality. Your approach truly elevated the learning experience and ensured active participation from all the attendees. The insights you shared, especially regarding the 2024 Global Market Report on virtual reality in gaming, provided us with a clear understanding of industry trends and future opportunities. Additionally, the survey on the scientific study of learning impact using laboratory simulations offered valuable perspectives on its effectiveness. So, the introduction to Laborster, an educational platform offering virtual laboratory simulations, which has great potential to transform how we approach hands on learning in various disciplines. We hope to have more opportunities to learn from you in the future. Thank you once again, and we truly appreciate your efforts and dedications. Let us now look forward to the next session, which promise to be equally informative and engaging. May I request our HOD, sir, the FDP coordinator, to introduce the next session speaker?
Right. Thank you, Ms. Sonia ma'am. Once again, on behalf of the organizing committee, I thank Professor Anand Kumar sir for sharing his expertise and helping us to enrich on this technology of immersive technology on VR, specifically in different application. Though this is the first session as an introduction about the immersive technology, specifically on virtual reality, he has made his job in a perfect way, helping us to understand on the different applications with the real-time applications and case studies. Once again, thank you, sir.
Thank you, Professor. It was my pleasure. Thank you.
So let me take the time to introduce the next session. Meanwhile, I also would like to present the overall session schedule. I request all the participants to mute your mic as well as the camera, which it is not required. So from today, this is the first day. See, I hope the screen which I would share, you could able to see it. Are you all able to see the screen which I shared? Right. So this is the overall schedule of ATAL Online 6 days faculty development program, and we have today is the first day. Starts with an inauguration and session one, which has been ended with the topic of introduction to immersive virtual reality by Dr. Annand Subramanian sir, is a professor from IIT Jammu, and followed by it, there's also another session. Very shortly, we'll start with the next session. So there are 50 percentage resource persons from industry and the 50 percentage from academia. We also have an international speakers, and we also have a 3 hands-on session. So the overall FDP in such a way, today it starts with an introduction, and the next session with focus to the tools for computer vision, and then we'll also understand the background modeling for a virtual reality, then the user interface and the user experience, then moving towards different tools and technologies support for the virtual reality to develop the applications that focus towards learning, teaching and learning. And then we also have the hands-on sessions on tracking and technologies using motion sensing in VR, and applying AI and machine learning in VR insights, and developing a real-time multi-user VR applications. Finally, the session ends with security and privacy in VR system. And the last day we'll have an online test. I also would like to convey to the participants, as per the ATAL instruction, a minimum of 80% attendance is required, and 70% of mark has to be gained in the assessment, which will be conducted as the last day of the session to receive the certificate from ATAL. So I request the participants to be on time. In every session, there will be a feedback link will be shared. Completion of the feedback link will help us to get your presence for marking the attendance. There also, by default, we will take a attendance based on your connectivity on time in the Gmeet link. So the completion to get the certificate requests an 80% of an attendance, as well as to secure the pass grade in the assessment, which will be conducted at the last day. With this, let me take an opportunity to introduce the next speaker for the next session. Is it visible, the screen which I share? Right. Thank you. So the next session's title is on interactive VR